Hello everyone, today we'll be looking at the quick solutions to the chemistry section of All India AIATS Test Series JEE Main 2020 Test 7 Code A and B. So let's start with the first question, students. Let us look at question number 26, students. It says 2 liter of an aqueous solution contains 2 mole each of NaH2PO4 and Na2HPO4. Okay. This solution is equally divided into 2 compartments. 1 Faraday of charge is passed and electrolysis takes place. Okay. One compartment acts as cathode while another acts as anode. Select the pH at the anodic chamber. So it is given to us that pKa1, pKa2 and pKa3 of H3PO4 are X, Y and Z respectively, and assume only electrolysis of H2O takes place in both these containers. Okay. So students, what is happening in this case is we had a 2 liter solution. So this 2 liter solutions contain 2 mole NaH2PO4 along with 2 mole Na2HPO4, and now this solution is divided into 2 equal solutions of 1 liter each. So now we have 2 equal solutions of 1 liter each, and if we talk about the moles of these given species, students, we know that they will both contain 1 mole each of NaH2PO4 and 1 mole of Na2HPO4. Okay. Now, students, the examiner is interested in the electrolysis and he is interested in the pH at the anodic chamber. So, students, at the anodic chamber, oxidation is going to take place. So, if we talk about the anode, so at the anode, what is going to happen is oxidation is going to happen, and it is mentioned to us that we have to assume only electrolysis of water. So students, this H2O will get converted into 2H plus half O2 along with the liberation of 2 electrons. Okay. So this is the reaction which is happening at the anode, students, and we can see that the number of moles of electron is equal to the number of moles of H plus which is generated. Now students, since 1 Faraday of charge is passed, it means that there is 1 mole electrons. It means that there is 1 mole H plus which is getting formed. Okay. Now if we talk about the anode, students, let us assume that the left hand side is the anode. So in this anodic chamber, students, we have 1 mole of NH2PO4 and 1 mole Na2HPO4. So this is acting as a buffer, students, and now when this Na2HPO4 is allowed to react with 1 mole of H plus, so the net solution is going to contain 2 mole of NaH2PO4 in 1 liter solution. So students, we have an amphiprotic species and we know that its pH is given by pKa1 plus pKa2 by 2. Okay, so the pKa1 value is X and the pKa2 value is equal to Y. So the pH at the anodic chamber will be given by X plus Y by 2. So students, if you look at the options which are given to us, we can clearly see that for this question we have to mark the correct answer as option 3. Let us look at the next question now. Question number 27. 2 first order reactions are given below. So we've been given reaction 1 and reaction 2. So in reaction 1, P is converting into Q and the activation energy is X kilojoule per mole. Whereas if we talk about reaction 2, C is converting into D and the activation energy is Y kilojoule per mole. Variation of ln K versus 1 by T for reaction 1 and 2 are given in graph. So the examiner seems to be interested in the correct statement. Okay. So if we talk about this plot of ln K versus 1 by T, students, we have K is equal to A e to the power minus EA upon RT. Okay. So we can take natural log both sides, students. So we have ln K equal to ln A minus EA by RT. Now students, we can clearly see that the slope is given by minus EA upon R, and we can clearly see that greater the activation energy, steeper will be the curve. Okay. So it is mentioned to us that the activation energy of reaction 1 and reaction 2 are X and Y respectively. Now there are some conditions given for X and Y, and for that conditions we have to identify the mapping of the line B and line A with reaction 1 and reaction 2. Okay. So in the first two options, the examiner seems to be interested in the case where X is more than Y. Students, when X is more than Y, so X is the activation energy for reaction 1 and Y is the activation energy for reaction 2. So when X is more than Y, it means that reaction 1 will be more steeper. So B will represent the first reaction, whereas A will represent the second reaction. Okay, and if you look at the option, students, option 1 it says if X is more than Y, then B is for reaction 2. This is not correct, students. B is for reaction 1. If you talk about the second option now, it says that if X is more than Y, then line A is for reaction 1. This is also not correct, students. Line A is for reaction 2. Okay. Now let us look at the next condition where X is less than Y for option 3 and 4. So if you talk about X is less than Y now, students, so when Y is greater, it means that Y will represent the line B. So when X is less than Y, it means that the line B will represent the second reaction and the line A will automatically represent the first reaction. Okay. So if you look at the options which are given to us, students, option 3 it says if X is less than Y, then line B is for reaction 1. This is also incorrect, students. If we talk about the fourth option now, if X is less than Y, then line B is for reaction 2. This is the correct statement out of the given one, students. So for question number 27, we have to mark the correct answer as option 4. Let us look at the next question now. Question number 28. Consider the below reaction. So A is converting into P. The concentration of P at time T is given by Pt is equal to A naught into 1 minus e to the power minus kt plus P naught, where K is the rate constant. A naught and P naught are initial concentrations of A and P respectively. The correct rate law expression for the reaction is. So students, we have been given Pt is equal to A naught minus A naught e to the power minus kt plus P naught. So we can rearrange it. So we have Pt minus P naught is equal to A naught into e to the power minus kt. So we can just differentiate, students. So we're going to have dpt by dt is equal to, the differential of the constant will be 0, students. So we're going to have minus A naught into e to the power minus kt into minus k. So this will be equal to k into A naught e to the power minus kt. So students, we can clearly see that this is a first order reaction. So we know that for the first order reaction, the concentration of A at any time t can be written as A naught e to the power minus kt. So this can be written as k into concentration of At. So students, we can write dpt by dt is equal to k times the concentration of A at any time t. So students, this is the first order differential equation and we can clearly see that the correct answer is given in option 1. So students, for question number 28, we have to mark the correct answer as option 1. Let us look at the next question now. Let us look at question number 29 now, students. Consider the following polythionic acid of sulfur, which is H2SnO6. If the average oxidation number of sulfur is X, then value of N in terms of X is. Okay. So students, it is a very easy question. It is based on the balancing of oxidation numbers. So we have 2 plus N into X, where N is the number of sulfur atoms and X is the charge on each sulfur. So this is the total charge on all the sulfur atoms present in this molecule. And we have 6 oxygen as well, so they carry a charge of minus 12. So this is a neutral molecule, so the total charge will be equal to 0. So we have N into X is equal to 10, students, and the value of N will come out to be 10 upon X. Okay. So if you look at the options which are given to us, students, we can clearly see that for question number 29, we have to mark the correct answer as option 2. Let us look at the next question now. Question number 30. Consider the molecules P and Q. So in P we have NH-SiH3 whole twice, and in Q we have N-SiH3 whole thrice. Okay. The examiner seems to be interested in the bond order between N and Si, and also the hybridization of the silicon atoms and the nitrogen atoms. Okay. So if we talk about the compounds P and Q, students, we have NH-SiH3, SiH3. So this is the compound P. If we talk about the compound Q now, so this is triethylamine. So students, in this case, there are 3 silicon atoms attached, and in this case there are 2 silicon atoms attached. So students, this Delocalization of the lone pairs will be greater in this case, as it has to be shared between 3 silicon atoms, and in this case it has to be shared between 2 silicon atoms only. So the bond order will be greater in this case. So bond order in P is more than that in Q. So the first statement is not correct, students. The bond order in P will be more than Q. If you talk about the second option now, the NSI bond order in Q is less than the NSI bond order in P. So this is a correct statement, students. If you talk about the third option now, in P, silicon is sp3 hybridized, while in Q, the hybridization of silicon is sp2. This is not correct, students. Silicon is sp3 hybridized in both the cases. If you talk about the fourth option now, hybridization of N in P as well as in Q is sp3. This is not correct, students. In both these compounds, the lone pair of nitrogen is delocalized. So nitrogen is sp2 hybridized in both these cases. So students, for question number 30, we have to mark the correct answer as option 2. Let us look at the next question now.